All right. Velocity and acceleration. What's funny is you've pretty much been taught everything you need already. All you need to understand is now, when you talk about the physics branch of calculus, it's no longer with respect to x anymore. And really, that's the only change for a lot of it. It's not with respect to x, but with respect to time when you talk about physics. Because you go from position to velocity to acceleration. It's basically how it goes. And the way I look at it, well, we'll kind of talk about it and see what you come up with. Average velocity is very, very much the same as average rate of change. Do you believe velocity is a rate of change? Basically, it's the rate of how does your position change. That's all velocity is. And if we're doing average, it's average rate of change. So it's basically the slope of that straight line that would connect the two endpoints. So in other words, the change in s, which is position, that's one of the standards for position, over the change in time. In other words, change in y over change in x. So in other words, just slope. Now, some of you may look at what you see right there, and you may think that's the definition of derivative. It's missing one very important part for that to actually be the definition of derivative. What part is it missing? Okay, the prime, not what I was looking for, but true. There's something that's missing right there.
Oh,
Limit as delta x goes to 0. So am I trying to reel in that other point right now? If I'm doing the, no, I'm not. I'm not trying to reel it back in. I'm just saying, here's one of my points. There's the other point. How are you going to find the average rate of change? Am I reeling this one back in?
no.
No, I'm just saying one of them's right there. One of them's right there. Find the slope. That's all you have to do. Isn't that exactly what we did when we did average rate of change before? Just found the slope. Period. End. Done. Okay. And that's all this is saying to do, because there is no limit. I'm not reeling it in. Okay, so this is average. Once you put that limit on there, then it's instantaneous at that instant. But that's not what we're doing. So basically, all you have to do is find slope. But I give it to you in a slightly different format. So there's a free-falling object, dropped from a height of 100 feet. Its height s at time t is given by the function, and that's an accurate function, by the way. You'll learn how to get that in a little bit. That s, or s of t, you could say right here, if you wanted to, s of t, s at any given time, is negative 16t squared plus 100. That, believe it or not, is taken into consideration gravity and everything for you. Where s is measured in feet, t is measured in seconds, blah, 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 blah. What's the average rate of change over the interval? So is this a point right here? Well, it's interval. It's saying go from 1 second to 2 seconds. So I want to know, on average, what was the rate of change there? So what we have to do is let's find the points. 1 comma something and 2 comma something. Right? There are 2 points out there, 1 second, 2 seconds. So how am I going to figure out the y value? Yeah. Yeah, you see, the only thing here is that this is s and t that we're talking about, but you can still talk about it as x and y if you want. That's completely up to you. So yeah, this is your time. So put it right there. You can do that, can't you? And so you take 1 second and you square it. Well, that's 1 times negative 16 is negative 16. Add 100. $84. So at 1 second, it is at 84 feet. So it has dropped, agreed? After 1 second, it should be lower than 100 feet, right? Because it was dropped, it says. You know, if I drop this marker, it will be not 100 feet anymore, right? I'm not at 100 feet, but you get the idea. If I'm at 5 feet, if I drop it after 1 second, it's not going to be 5 feet anymore, right? How about at 2 seconds? How about this object that we're talking about here? Well, put 2 right in there again. You got to square it, take it to negative 16, add 100, and what are we looking at? 36? So do you agree those are the 2 points? So am I asking you in this problem to tell me the rate of change at just this point? Am I asking for it just at that point? No, I'm asking if you went all the way along that path, what's the average? On average, how fast are you going? Okay. So all you have to do is do slope, however you want to. If we follow our little formula, take y2 minus y1, right, over, you gotta be careful on this one. Make sure you do it the right way. So if we're gonna do it our way, right, we went this direction, right? So go in that direction. So minus 1. I got the bottom. I'm on that. Nope. It is negative, though. I'll give you that. Negative 48. Negative 48 what? Why feet per second? Where? Yeah, isn't the bottom time and the top feet? So feet per second. Get it? Do you believe that? Well, I'm just going to graph this over here. I don't know. Let's check this out. And the great thing about physics is you don't have to worry about all those quadrants. That's nice. All right. So 1 comma 84, huh? So 1, I don't know, 84. Let's say, well, 0, 100, right? We dropped it from there. This is just a position time graph, all right? Position time. I know you've heard that before. Yeah. All right. So here's 1 second, right? And now at 1 second, we're apparently at what? 84, right? And at 2 seconds, we are at, whoa, that's down there a ways, huh? 36. So do you agree that this follows some kind of path like that? Right? Your position time graph? Oh, imagine that. This is an upside down parabola. No way. No way that happens. All right. So what did you just find? Well, you said if I was there and I was there, again, could you add up all these rates of change and then find their average? You could, but you'd be here all day. And then some. But basically, well, that's horrible, but you get the idea. You find the slope of that, and that is the average. Could you agree some of these are a little steeper that way, and then these are a little steeper the other way? They're going to average out. And don't you agree that that slope's going to exactly happen somewhere in the middle anyway? Because this is a continuous graph, right? As it keeps on going. Okay. So we know that's going to happen. So that is that believable, that slope that we've got in there, that slope is negative 48? Oh, I think so. I believe that's pretty good. Yep. Because it'd be basically, down 48 over 1. Okay. All right. So how about from 1 second to 1.5 seconds? Based on our graph, do you think the average will be, what do you think? Is it going to be negative 30? Is it going to be negative 57? What do you think, just in general? Do you think if I go from 1 to 1.5, looking at the graph there, do you believe that it'll be more negative or less negative? Maybe I'll put it that way. Because I hope you agree that it'll still be negative, right? The slope there, right? Okay. You think it'll be less negative? Okay. Well, let's find out. And how will we find out? Well, I just wanted to show you a graph. Yeah, this is the answer. Yeah.
Can we put it like
well, yeah, you could do it like that. It's negative 48 feet per second. Yeah. Yep. You don't have to put over 1 and all that stuff. That's fine. Well, how are we going to do this? We got to do average. I don't want instantaneous. I'm not reeling that thing back in. So it's, well, hey, we did this one. I got this one. 1 comma 84. I know I'm so helpful. 1.5 comma, is it also 36? The y value? No, that's not the same. Oh, boy. Well, somebody go and find that. It actually comes out to a halfway decent number. So, well, because I made it that way, but. Anybody got that y value yet? No. 64 is what I got, yep. How would you get the y value? Would you plug that into some derivative or something? No. Or the, I'm sorry, the height value, the s. All right, find the slope. And I know that you're not very good at it yet, but that's all that's saying. in that red box there, find the slope. It's all the same. Change in position over change in time. Nothing major. So what do we got there on top? Is it okay if you go this other direction, like that? Is it okay to do that with slope? Yeah, as long as you do the other one the same way. So I'll just trick you up here a little bit. 84 minus 64, and then I better do 1 minus 1.5. Let's see if we get the same answer you got. What's on our top? 20. Over negative 0.5. And of course, you're not going to leave it that way. You're going to figure out what that is. Well, it's dividing by a half. In other words, multiplying by. So in other words, negative 40 feet per second. So did some of you say less negative, I think is what you said? Is that right? Because remember, you had that parabola, and we started from here to there, and we found that slope, right? Now we're only going from here to there, right? Is that going to be less negative? In this case, it would, wouldn't it? Because this is the steeper you go, the more negative it gets, right? Because this apparently will be down 40 over 1. Yes? Right. Well, like I said, you could do it either way as long as you follow the pattern. You would have a negative on top and a positive on the bottom. So it'll work out the same. So what do you think from 1 to 1.1? More negative, less negative? What do you think? Just looking at the graph, less negative. Why don't you go ahead and do C right now on your own? Well, let's see how good you did. 1.1 comma what? This wasn't as nice of a number. Yeah, 80.64, so not as nice. And so then you do your slope, and you come out with about negative 33.6 feet per second. Okay? At least that's what I got. Again, that's on average. If I took all of those times into consideration between 1 and 1.1, added them all up, divided by how far I went, that's what I would get, negative 33.6. But of course, we don't want to do that. And so we just do the slope. Okay. Questions on average rate of change. That's your secant line, basically. Instantaneous rate of change, or instantaneous velocity with respect to time. Instantaneous is when you reel it in. You've got that point you want to know something about, you throw it out there at some other point, and you reel it back in and find out what slope is. Which is why you see that slapped on to the average rate of change formula. It says, I got this first point, throw it out there, reel it back in. And again, you see that it is basically S prime, or the derivative of position. So basically, here's one way you could look at it, at least how I look at it. Position is kind of your starting spot here. And I look at derivative as going down one level. That is velocity. Because velocity is how does your position change over time. It's a rate of change. And just so you know, velocity does have direction. So positive and negative does mean something slightly different as long as you know which way is positive, which way is negative. Whew. Well, good thing we don't have to do this one by the definition anymore. So it's determined the velocity at time equal 1 and time equal 2 of a free-falling object. So is it saying over that interval? Is that what it's saying? No, it's saying at 1. It's saying what is the rate of change? So if I'm asking at that point, is that a secant line I'm talking about or a tangent line? Tangent, right at that point, what's it doing? And right at 2, what is it doing? And so this is more instantaneous. So S prime of t, which is otherwise known as velocity, is what? What's the function? Nope. Nope. Maybe we should go back to the definition. Apparently we're better at that. I just took the derivative. Yeah, which is what that says. S prime of t is v of t. It's the same thing. Is negative 32 t. All right. So now I need to know at time equal 1. So S prime of 1 is really what I'm asking, otherwise known as V of 1. time equal 1 right there for whoever said what. So I'm putting it in place of t. That's the time, right? So negative 32 times 1 is negative 32. Negative 32 what? 5 feet per second. How come that feet per second squared? Not true. We only took it with respect to time once, which that's why. Because if you take velocity, it is position with respect to time, just one time. How about at time 2? Let's see if you can give me a general idea on this one. I always run out of room. Do you agree it's the same graph as the first one? Right, something like that? And t equals 1 was up here at, what, 84 or something like that? So you just told me that that slope right there is negative 32. So what do you think about this one right here at time equal 2? It's about there. Is that in itself, is that steeper or less steep? Steeper, so is that going to be more negative or less negative? More negative. So it's s prime of 2, because that's the time I want to know. So put it in for t, so which is also known as v of 2. No. Sorry. So do you agree with that, that this one is definitely steeper than that one? Does this help you with the difference between average rate of change and instantaneous? Instantaneous is saying, right there, how is it changing? Right there, how is it changing? What's average saying? All the points in between, and the easiest way to do that is this. Well, you're finding slope in both of them. That's the tricky part. Technically, you're finding slope in both of them. But you can look at it this way, that average rate of change is you're finding the slope of the secant line, or in instantaneous, you're finding the slope of the tangent line. Yeah. You're saying, here's the point I'm at, and I'm going to throw out to that other point, and I'm leaving it there. I'm going to find the slope. You're casting out to that other point, you're going to leave it there. What's the slope? Instantaneous is you cast it out to that other point, and you reel it back in. These two are pretty important to know as well. Speed. Speed does not have direction, which is why it's the absolute value of velocity. So whatever answer you get for velocity, you just take the absolute value. So what is the speed of the object at time equal 1 second in this example? 32 feet per second. Okay. And at time 2, the speed is 64 feet per second. Speed has no reference to direction, positive or negative. Velocity does. And acceleration is basically with respect to time again. Because let's face, could you be traveling in your car somewhere? Sure. That's basically your velocity, depending on whether you're going towards the positive direction or negative direction. What if you hit the gas? Has your rate of change just changed? And has it changed with respect to time again? Yeah, it has. So that's what acceleration is, or it could be deceleration if you hit the brakes. All right. Acceleration also has direction. Okay. For example, if I was in my car and I was in, say, it doesn't matter what gear you were in, but you were rolling backwards down a hill. You could say that you're, for those of you that aren't good with the clutch, maybe that's what you do. You start rolling backwards down that hill if you're on one. You really want to go forward, but you're going backwards. All right? And you're having trouble with the clutch. Your velocity in this case, if you're considering forwards being positive, the velocity is a negative, correct? When you hit the gas, let's say you are in drive, okay, or you actually lift off the clutch and keep the car running, and you're trying to go forward, do you agree that your acceleration is positive? So velocity is negative, acceleration is positive. Do you speed up or slow down? Think of the situation I just gave you. If you kept the car running, you were rolling backwards down a hill because you're having trouble with the clutch. You finally got the clutch to work and you were in drive or in first. Would you overall be slowing down or speeding up? Because the two are, one was, yeah. So the same thing works as if you do that the opposite. If the two signs are opposite, that's how it works. What if they're the same? For some reason, you were going backwards, you were trying to go drive, but somehow it slipped into reverse. And then you hit the gas, pulled out the clutch. Are you speeding up or slowing down? Speeding up. Apparently that's happened to somebody in here because that's awfully funny. All right. So determine the acceleration of the free-falling object. But wait, what did I give you? Did I give you velocity? Did I give you position? How do you tell? How do you tell? I just want to know, what did I give you? Nope. Nope. What does S stand for in these problems? Position. This is the position function again. Hint, hint. Yeah, that darn reading, I tell you, just gets in the way. That's position. I need to get to acceleration. Well, back here, I just told you that it goes position to velocity because that's with respect to time once. With respect to time again is acceleration. So in other words, if I'm starting you at position here, I'm taking you to velocity. That's with respect to time once. I do that with respect to time again, and that's acceleration. And so this is S. So if I take S prime of t, do you agree that's really just saying velocity? Those two are interchangeable. Okay. These you could say S prime of t, or you can just say V of t. It does not matter. And what is that? Let's see if we can do a little bit better this time. There you go. Now, S double prime of t, remember you can take the derivative many times, correct? Is also known as just V prime of t or A of t. It's funny how they came up with A of t for acceleration, V of t for velocity. And we'll talk about why S of t is position later. All three of these are interchangeable. Doesn't matter which way you say it. And so what do you have to do to that negative 32t? Oh, take the derivative again. Okay. All right, now we're on a roll. I did. Now we have to discuss this answer. Do you agree this is the same free-falling function I've given you all day? Right? It's the same one. I haven't really changed it. So what is that? Yeah. Or what's the label? Can anybody tell me that? If that's the same function that we've had all day, it's been feet and seconds, right? That's what we're talking about? It could be, you know, miles and days, but it's feet and seconds here. So can anybody give me a label on that? Feet per second squared. What you need to do for tomorrow is tell me, what is that? Negative 32 feet per second squared. What is it?